Okay, welcome everybody to today's webinar. Today's topic is active learning for administrators. Before we proceed with the webinar, if you could please use the Q&A box that you should see there on your screen and let me know that you can hear me and see me. And this is also the box that you'll use throughout the webinar for questions to let me know if there's something that you have that you would like me to answer. We should have plenty of time at the end of the webinar for questions as they come in. Okay, looks like we're good. And if you do have problems with audio, you can ping me there too and make sure that it's on your side and not globally. Great, so I guess I should introduce myself. My name is Jeff Gillis and I am on the solutions team here at Relativity. The contents of today's webinar are in a few different sections. So we're going to start with an overview of active learning, the product, the application. We will then, and that's going to be some slide work for the most part. We'll then proceed into a demo, a live demo of the product. I'll show you how to set up a project, how to start and stop the review queue, what it looks like from the reviewer's point of view, how to monitor your project, and then we'll talk about how to conduct an illusion test when you're done. And then lastly, we will talk a bit about coverage review, which is a new queue that's available. It is a little bit different than the prioritized queue, so we'll talk about that some as well. One last thing before we get into it, sorry, a little public service announcement. Any questions that you have that we don't get to today, any questions that you have as you get into using this product more, frankly, any questions about workflow in the product, please feel free to reach out to solutions@relativity.com. My teammates and I love getting questions about active learning. We love getting questions about the product, and we're here to help you. So please do use that resource with anything that comes up. So with that, let's get into talking about this product a little bit. So what is active learning? What is the Relativity active learning product? Well, it's a TAR capability. It's technology assisted review. It's a capability that exists in Relativity. And why do we have it? Well, it provides for efficient and accurate classification of your documents. It's the things that we prioritized when we were building this product. We wanted something that was easy to get moving with. We wanted something that was going to provide very little work on your part as far as monitoring it, so that it's easy to kind of administer. You don't have a lot of points where you're the critical path as the administrator of this product, but it's very easy to passively administer. And thirdly, we wanted the reviewer experience to be strong for the actual people reviewing the documents. So those are really the three primary goals designing it. We built this product kind of in addition to our previous TAR product, which is called sample-based learning now. Its nickname is RAR. So both of them exist side by side. I think because of some of the lessons we've learned through the years, we've done a pretty good job of hitting those points, as I said, and so we are seeing a lot of adoption of active learning versus sample-based, but both are still available in the product. So some of the differences between this product and RAR, one of the key ones is that the algorithm is different. So we've chosen to use an SVM algorithm, which stands for Support Vector Machine, for powering active learning. So if you're not familiar with SVM, it's a machine learning technique, and its whole role in life is to do binary classification, which is to say, in our world, typically responsive and non-responsive, but it could be hot and not hot. It could be interesting and not interesting. Any question or any classification that you can phrase as far as X and not X, you can use a binary classifier on, provided it's able to classify off of the data that you have, which in this case is the extracted text. So SVM learns from coding decisions, and specifically, it takes the coding decisions and the text of the documents that those coding decisions apply to, and it uses that to try to figure out how documents are responsive or not. Like, what are the words in the documents? What are the phrases in the documents that make them responsive or not? So the responsiveness or the hotness or whatever your categories are is really going to boil down to a rank from 0 to 100 and a prediction that goes along with that rank. So 100 means the most likely to be responsive, a 0 means the least likely to be responsive or the most likely to be non-responsive, and then somewhere in between is where things get murkier. But basically what you do is you have all of your documents scored, you cut it off at some point and say, okay, 51 and above is going to be responsive, 50 and below is going to be non-responsive, or maybe in another case you choose 60 and above and 59 and below, but based on that cutoff, that's where your prediction essentially comes from. But you always have that rank as a kind of a strength of prediction as well. So why do we choose this classifier? Why do we choose this product? We did not invent it. It's something that's very prevalent in the world of machine learning and classification. It's been proven in a variety of applications, both inside and outside of text classification. And some things we like about it: it performs well, it's fast, it does one thing and it does that one thing really well. Some of the things that we like about it as well, and that we hear reinforcement from people using it, is that it's good at resisting some incorrect decisions. So you have one of your reviewers not performing as well as the others, the system's kind of able to compensate for that, or able to see the predominant theme that's coming through. So that's good. Because any system that relies on perfection from the human inputs is going to struggle to achieve that. So overall, we like the results. We like the quality of classification that we're getting out of it, and we've been quite pleased, I would say, with this algorithm. So let's talk about the process overall, the active learning process. So active learning basically works by, as we said, we submit the coded documents that have responsive or non-responsive decisions. The model, the SVM model, is then going to update based on what it sees, and it does this update in the background every 20 minutes as you're going. So you're coding documents. The system is always trying to get smarter. It's got a growth mindset. It's always trying to get better. And then it's going to rank the documents after it updates the model. So it's going to always be every 20 minutes rebuilding the model, re-ranking the documents, getting smarter and smarter, and allowing you to really proceed with getting the best prediction that you can have based on the documents that have been coded. How's this thing put together? Well, everything in relativity starts with a safe search, right? So it is going to start with a safe search. That safe search then feeds a classification index. So as we'll see, a classification index it's a type of analytics index. It lives alongside your conceptual analytics indexes in the same place in the product, and it is going to those two are tied together, and then from there, the classification index is tied into the active learning project. So you set up your safe search, you set up your classification index, and then you're going to have your active learning project. It's going to take the classification index, it's going to take a designation field of responsive or non-responsive, and this is what it's going to learn from. And thirdly, it's going to take a permissions group. So this one's a little different maybe than you're used to in relativity assisted review, for instance. But the permissions group is there so that you can define who gets to be in the queue. So if a reviewer is in this permissions group, then they have access to the queue if you grant it to them. We'll talk about this when we get into the demo. So the active learning project then creates those review queues, and there's a few different review queues. There's a prioritized queue, which we'll talk a lot about. There's a queue associated with the illusion test that we'll talk about, and there's a queue associated with the coverage review, which we'll talk about as well. What does this queue look like? So the queue, the prioritized review queue in particular is it revolves around your reviewers. So here you have a couple of reviewers, and what are they doing? They're reviewing documents, they're calling them responsive and not responsive, and those documents are being fed to the engine. The engine, the model, is then building, and it's ranking all of the documents in the universe. In particular, it's ranking the uncoded documents. So there's certain documents that you haven't coded yet. Those are going to be ranked. When the reviewer in the prioritized queue clicks save and next, they're going to receive the next highest ranking uncoded document. So it's kind of like, what's the best thing you got on the list? That's the document they're going to get. There is some mixture that comes in here as well. There's some other documents that are mixed in, but primarily they're getting those highest ranking documents. So they click Save and Next, they get a high ranking document. The other reviewer clicks Save and Next, that reviewer gets a high ranking document. Of course, the documents are subject to permissions. So if I'm not permissioned to see a document, then I won't see a document. And of course, there's no collision. So if I see a document, then my colleague will not see that same document. They're fed to different reviewers. Occasionally, the model is going to rebuild itself, and it's going to re-rank the documents. As we said, every 20 minutes, it gets smarter and smarter. And so as that happens, that kind of happens transparently in the background. The reviewers continue to code and continue to see new documents. So the overall workflow, we're reviewing, the admin is monitoring how things are going, and in particular, at some point, right, there's a finite number of responsive documents. At some point, you're going to start running dry, and you're going to stop seeing responsive documents. At that point, you might want to kick it over into the validation mode, which is where you conduct your illusion testing to determine the documents we haven't looked at yet. Is there much in there that's worth looking at or not? And we do this with a random sample. So I apologize if I'm going a little quickly. I do want to spend some time in the demo. So graphically, we set up the project, we start the queue happens and people are reviewing and I'm monitoring and seeing how things are going. And then at some point we go and validate that work product, validate that the predicted non-responsives look good. So here you see a screenshot of the project. So this is the active learning project screen. There's a couple of graphs on the screen for you that you can see, and you can get a sense of what's going on in your project. So the first graph is this histogram. What you can see along the bottom is there's numbers from 0 on the left to 100 on the right. So those are those rank scores. So what I see here is I see a bunch of blue documents at about a score of a 70 to 85. So for us, those are pretty strong scores. Those are pretty highly responsive scores. The blue tells me that a reviewer has coded that document as responsive. The fact that it's got a high score means the system thinks it's responsive. So that kind of agreement is certainly a good thing to see. Likewise, on the left side of the screen, we see some yellow documents, which means they were coded not responsive. They're low numbers in the high 20s, low 30s. This is a very strongly non-relevant score for us, and so that's another good thing. In this particular screenshot, we see what is really the most valuable thing about a project or a product like this is that big pile of purples on the left. So what a big pile of purples on the left, the purples have not yet been looked at. We haven't paid anyone to review those documents. And the system is saying those look really non-responsive to me. So basically this is detecting the stuff that's not likely to be of interest to us. When we go and run an illusion test, those are the documents we'll be sampling to just make sure that everything's working well. In this screenshot, there's this vast wasteland in the middle. This is a wonderful thing to see because those are the ranges that kind of 45 to 55 in particular. Those are the ranges where the system is not sure about a document. So in this project, you see there's very little in there that the system is not sure of. So that's wonderful. That's not always achievable, and sometimes, frankly, documents in the low 50s can be 20% responsive, and maybe that's significant for you, depending on the richness of the project. But this is certainly an ideal thing to see. And then at the bottom of the screen, we have our prioritized review progress. So I'll spend a moment on this. So we're using the prioritized review. The reviewers are looking at those highest ranking. What's the best document you got, right? What's the best wine on the menu? At some point, we sell out of all the good wine, and so the best wine on the menu is lower and lower quality, and then at some point, the best wine on the menu is terrible. So what this prioritized review progress shows you is what is the rate of responsiveness of those high-ranking documents at this moment in time, or in the last 200 documents that have been seen in that queue. So it's going to start out very high. It's not uncommon to see it at 100%, at 99%, because early on, the model's starting to hit its stride. It's predicting really well, and then at some point it starts decaying. It's probably not going to be quite as sharp as you see here, but at some point you go from scores in the 80s to 90s to scores in the 50s or 60s, and then it'll drop even further. And then at some point you might have scores of 2%, 3%, 5%. Now, if you have, 20% responsive documents across your project and you're only seeing 5%, you're starting to ask the question, is it really worth it for me to keep going here? And that's the time that you might want to consider doing an illusion test. Okay. So let's talk about illusion a little bit. What is it for? It's for assessing how trustworthy is a non-responsive prediction on a document that the system has not seen yet. You typically do this at the end of your project. We'll talk a little in the coverage queue about how you might do it earlier in a project, but typically you're doing it at the end of the project. And basically what this is it's a measure of the error rate of a predicted non-responsive document, a low-ranking document that hasn't been seen yet. What is the chances that it's actually responsive? If you came from RAR experience, this is basically a non-responsive overturn rate. That's the RAR terminology for this feature. The nice thing about how it's been built into the product is that it provides its own queue and it takes care to freeze the model for you. The reason that it's nice to freeze the model is that it's not moving out while you're measuring it. So here you are measuring, seeing how good it's doing, and then oops, it changed. It doesn't do that. It freezes the model. It lets you code those documents in the same way that you coded all the other documents in the queue, and then it's able to report on how well things are done. Okay, so we're going to switch over to a demo. I'm quick going to check on the questions and see if there's any questions that I can't just answer in the demo. Okay, we'll talk about that for sure, and we'll talk about that for sure, and sorry, you can't see what I'm seeing, but okay, so I will try to hit on all these things, and I will come back to them if need be at the end. So let me flip over to my demo here. Voila. I'm going to hit F11 to go to full screen. So you should be seeing my relativity screen now. So here you can see I am on the Active Learning Projects tab of the Assisted Review tab. I'm actually going to start by showing you how to build that index. It's super easy. It'll take just a second. So here you can see a bunch of analytics indexes. Some are called conceptual indexes. Those are for the LSI-based indexes for doing things like clustering and keyword expansion and concept searching, categorization. And now we have this new index type called classification index. So when I click from conceptual to classification, what you'll see is that all of my complicated configuration goes away. So all we have here is basically a name and a searchable set. So I'm going to call it classif index. Now there's only one thing you can screw up here, and please don't do that. So the important thing to do is to pick a save search that brings back just extracted text. This is the same thing that happens when you do a DT search index. Typically, it's the same thing that happens when you do a conceptual index typically. So make sure that you're bringing back just the extracted text. That's the one thing that I ask. Typically, the project will build if you bring back other fields, but it won't yield the results that you think because it's not looking at the text of the documents if you don't give it the text of the documents. So you do that, I would click save, I would click populate, and my index is ready. It's a quicker build than a conceptual index because all it has to do is push the text over. So that's basically the infrastructure for active learning to use. Nothing to it. One point I should make, what documents to put in that save search. Typically, I would say it's similar exclusions to with conceptual indexing. So don't give it empty documents. A lot of people just cluster their conceptual index and exclude all the unclustered. Don't give it JPEGs and MPEGs and media files, all those things. documents that you know have bad extracted text, you can predict are not going to classify very well. So anything you can do to kind of move those out of there and just subject them to other forms of review is best. And usually people just kind of build that into their templates. So let's jump over into our active learning projects tab. Well, let's start with a kind of an early stage active learning project. So I'll show you, this one was set up with a pointing at a classification index. It also points at a review designation field, which is a single choice field with two choices. And then you have to specify which is the responsive or the positive choice, which is the negative choice. And that just tells you, is a high score responsive or is a high score not responsive? The positive choice says what a high score is. There's a setting called suppress duplicates. This is typically turned off. You see it's on this project, but we typically advise that you turn that off, especially if you're doing a standard prioritized review, which is what we'll mostly focus on here. And then you can see there's a responsive cutoff you can set. You can change that over time, but that's just where you kind of see the responsives and the non-responsives changing. And lastly, you can see that I've got a reviewer permission group. Again, this just defines who gets to be in the queue. So I'm going to pause for just a second. Okay, there are some questions coming in. I think that most of them are going to be part of what we talk about, so bear with me for that. In an early stage project, the reason I can tell it's an early stage project is, first of all, there's not very many documents coded. There's only 48 documents coded total. But moreover, this graph, this histogram, is basically a big pile right around the middle. This tells me that the classifier doesn't really know much. If it looks like a single bell curve centered it in the high 40s, that's a pretty good sign that you have an early model that doesn't know very much. It's important to note that you can interact with this graph, so I can look at just my coded non-responsives and see where they lie in the graph. I can look at just my coded responsives and see where they are. Yellows tend to be on the left, blues tend to be on the right. Maybe I want to look at just my not reviewed. So please do interact with that graph to play around with that. The other thing you can always do is you can pull the scores into the documents table and kind of play with them yourself. So that's called updating ranks. We'll talk about that a little bit later. So here you see my prioritized review queue, and you can see that the queue is active because the card is lit up. It's not grayed out like these other guys, and you can see that there are 19 reviewers in that queue. Now, those 19 reviewers have basically coded 4 documents responsive and 9 documents not responsive, because I've got some manually selected documents as well as my queue documents. So seed sets, if you want to pre-code some documents as responsive, you can do that as long as those documents are inside your saved search and they've got a decision on them. They will be used to train the model. There's absolutely nothing the system does to prevent a coded document from affecting the model. So if the document was coded with a mass action, if the document was coded using some other layout, some other review, any of those things will help you train the model or poorly train the model, depending on what those documents are. So as long as they're in the project and they have a responsive or non-responsive designation on that field, they will help train the model. If I want to add or remove reviewers, I just click this Add Reviewers button. I can see people in there. I can maybe say, okay, let's take Jeff out of the project. Jeff's no longer in the project. Okay, I changed my mind, put him back in. So you can add or remove people. You can add everyone at once. Click all users, any of those types of things you can do. And then accept the changes or cancel the changes as you wish. So that's just going to allow the reviewers to see the queue or to not see the queue. Generally speaking, I think a best practice is do go target some responsive documents. The system needs at minimum 5 responsive and 5 non-responsive in order to build its first model. But if you can code some documents ahead of time, particularly responsives that tend to be hard to find, that's just going to warm up the model. Another thing that people like to do, it's always good to know what your richness is, what percentage of responsives are out there. So you could take a small random sample of your whole project, code those, That tells you approximately how many responsives to expect, and those could also be fed in for some further training. So those two things, if you do those prior to starting that review queue, you're just going to get a little higher quality documents right out of the gate. So the prioritized review project progress graph in this case hasn't even started yet because the reviewers haven't started coding. But once they've started, but they haven't coded 200 documents. Once you've coded 200 documents, that graph will start to display. One other thing you can get at from this screen is you can jump over in your statistics and you can just see kind of tabular format of some of what's going on. So you can see there have been 25 manually coded documents coded outside the queue, of which 10 were responsive and 15 were non-responsive. You can kind of peruse this information down there. So let's talk about the reviewer experience a little bit, and then we'll go look at a more mature project. So if I'm a reviewer and I've been added to the prioritized queue, or to any of the queues, frankly, what I'm going to see is I'll come in, I'll see a view associated with the name of the project. So the one we were just looking at was called New AL Project. And then a Start Review button at the top of the screen. Now you'll notice that I don't see any documents here. Typically, if I'm coding a batch, I'm going to check out that batch. I'm going to see the batch on the screen. In this case, there's no batch. That's because what this view shows me is documents I've already coded, not documents that I'm about to code. The documents that I'm about to code are sitting in the system, and they're ready and raring to go as soon as I click Start Review. So I click Start Review. What's going to happen is the system will bring me into the viewer, and it will feed me a document. It's as simple as that. The only coding instructions you need to give your reviewers is to say, please code the documents on what we call the four corners rule. So code this document based on just its extracted text, just what you see within the four corners of the document, whether you're using the viewer, whether you're using the extracted text feed. The reason for that is because you don't want to mislead the system. So if there's an email that says, please see attached, and you say that's responsive, then that tells the system that one of those words is very responsive. But of course, if we don't know what's in the attachment, we don't know whether it's a responsive phrase or not. So even if you know that document will be responsive because the attachment is responsive, you could always not code it on the designation field. Maybe you give your reviewers a layout that allows them to say responsive for family or something like that, or you just say, well, later we're going to do safe searches to find responsive attachments and code their emails as responsive. So the best practice in this type of a product is to code that designation field on things that will teach the engine and not throw in, not intentionally confuse it. Now, that being said, we said that it's resistant to some problems. To some degree, it would eventually learn, for instance, that please see attached is not a very responsive thing, because it would start bubbling up documents that say please see attached, and then you say, well, that's not responsive, and then it'll start saying, oh, I guess that's not those aren't words that are highly tied to responsiveness. But generally speaking, just say code the document for responsiveness. If it's responsive for a reason not within the four corners of that paper of the document, then it's best to not code based on those things. I did get a couple questions about document count. How many documents do you need to run this thing? You really need 10, 5 responsives and 5 non-responsives. Now, it's probably not worth starting a project if you only have 10 documents and they've all been coded. But really, you can start very small. If you had a few hundred documents, you could start coding them in here and then add more documents later. You just update that index and add more documents, and they'll all start receiving ranks, and they'll all start getting served up. You know, the actual practical bottom limit is probably around 1,000. But I've certainly, because of the ease of use, I think this is a much more approachable way to go for smaller projects. So even if you have 2,000 documents, if you have 2,000 documents and one attorney that's reviewing documents for 20 minutes a day, this is a great way to focus that person on the high-ranking documents, because it's very easy to get into. They code the document, they click Save and Next, and they're just going to get fed more and more highly responsive documents. So not too much of a technical lower limit, but as I said, there's kind of a practical lower limit. Probably probably a few hundred, you might be able to get value out of that. So You do have available things like email thread visualization, things like related items. If I want to see, you know, the email thread group or the attachments, I can click on those. The only thing I'll point out about that is if you jump in, I'm on the wrong set here. If you jump into to these other documents, you will, when you code them, they'll show up as manually reviewed because the queue did not serve up the document. It came in as a +1 with a document that came in through the queue. So it's fine to code them. If that's your workflow, that's no problem. I would just say, do code them on the 4 corners on this responsiveness field, and be aware that they'll show up not as queue documents, but as manually coded. So manually coded is just any document that received a coding decision not from the queue. There's a concept of a skip document. That just means I didn't make a decision and I just click Save and Next. So if I click Save and Next without deciding whether it's responsive or not responsive, that's a skipped, and you can go query on those later, and you could have a second reviewer go look at them. This reviewer could come back and go look at them. It just means no designation, but it was saved in the queue. So that's really it from the reviewer experience. If I code, click Save and Next, and code, and click Save and Next, and code, and click Save and Next, I can do that basically until there's no more documents in the project. There's really no end to what the queue will give me, the reviewer. So that's where you as an administrator might be looking at the project saying, gee, I think this project is done, but the reviewers don't need to stop. They're just going to keep going and going and going. So let me jump over to my projects, and I'm just going to show you what a later stage project looks like. I'll talk a little bit about update ranks, and then we'll talk about the illusion and the coverage queues. So this is similar to that project I had on the screen. It's a second project. You'll notice that I've had multiple projects on the same workspace. That's absolutely something you can do. So you could have projects for different types of responsiveness if you wanted to. You could have a hot docs project and a responsive docs project. They could use the same designation field if that makes sense to you. They could use different designation fields. Tons of flexibility. The only real restriction is that each of these projects has to have its own index backing it. So if you want 3 projects, you create 3 classification indexes. But other than that, no problem at all. So this project is a little more mature, or quite a bit more mature than the one that's a big bell curve in the middle. It's still kind of a bell curve, but it's well over to the left side. And as I said, scores in the 30s and 20s and 10s, these are highly, highly non-responsive. You should not interpret these as probabilities. This does not mean it's a 25% chance of being non-responsive. It's probably like a 1% chance. It's really lumps. The lump on the left is highly non-responsive. One reason I might choose to do an illusion test at this point is because of this bottom graph. So as we said early on, we were getting 85% responsive, 81, 80, 92. And then when I got to my 3200th document and its friends, my 3400th document, now my relevance rate is down at 6%. So that might be a sign that I want to go and start my illusion test. You can see I've only coded about 4,000 documents. A prioritized queue is not primarily associated with like build the model as quickly as possible. It's really associated with focus on the most responsive documents first, and then either stop when you've run out of responsives, or frankly, you could keep on coding. Like if you kept on coding until every one of these purples is done, you're allowed to do that. But just know that your days are going to get really long, or your reviewers' days are going to get really long as they just see non-responsive after non-responsive after non-responsive. But we absolutely see people using this, even going end to end, reviewing all 64,000 documents. It just allows them to really focus on those responsives first and prioritize those for downstream workflows and all the rest. So again, the drop in the relevance rate tells me I should probably run an illusion test. The other thing, as I said, that we can do is we can update ranks. So at any point in time, you can click this update ranks button. And what this is going to do is pull down all of the scores for every document in the project into the relativity documents table or into the categorization results set object, frankly, but it's reflected to the documents table. But I can get all the scores for all the documents, and then I can slice and dice those scores however I want. So click the Update Ranks button. It's going to blow away all the previous scores, add all the new ones. If you wanted to keep them, you could always export them beforehand. But updating ranks is, I think, kind of an essential. It's not kind of. It is an essential way for an administrator to peek into what's going on. So that's something I very much advise you do. Most people do it kind of at the end of the day. Everyone's done reviewing, so things aren't moving around very much. They pull down the ranks, and then in the morning they go and slice and dice and kind of see what's happening. So let's take a quick peek at a dashboard over there that I like to use to administer my projects. So you can see I've got an active learning project admin document view, and I've got an active learning admin dashboard that's tied to it. So what do I have here? I have a histogram at the top that's basically a reproduction of what I saw on the other screen. My colors are different, but I've got non-responsives on the left and responsives on the right. I've got some pie charts that allow me to see what is the active learning designation, what is the categorization prediction, where the active learning prediction. So is it predicted non-responsive or predicted responsive? I see when was a document coded in the queue. I see who are my reviewers. And so I can start QCing here. So one thing that's of particular interest is documents that were coded not responsive, okay, yellow, but that were predicted to be responsive. So this is where a human said it's not responsive. The machine says it has a high score. What are those? So I've just added two conditions: coded non-responsive, predicted responsive. You can see I've got one document that's 65, three at a 66, etc. I can see when were those documents coded. Perhaps they were coded early on in the project and the definition of responsiveness has been changing. Perhaps they were coded by someone who started the project and then stopped caring, and so whatever. Like this allows you to drill down into what the reasons might be. I can see who did it, so maybe it's all Bill Bailey's fault. He's the one that's been coding them. But of course, you can also get down to the documents themselves. So maybe the issue is that these are Excel spreadsheets, and it's difficult for the system to see the responsiveness because the responsiveness is based on, well, if the cell C24 is greater than 500, then it's responsive, and if it's less than 500, it's not responsive. That's the kind of thing that a classifier like this is not able to really see. So that could be a good reason that something is amiss. So this type of dashboarding, I think, is really essential for an administrator. Again, you update ranks, that'll give you the scores, and then you can start building these. This dashboard is described on our website in our recipes section. So there's an active learning useful dashboards recipe. Please go look at that. It's also in the resources of the deck. So I am going to move over to talk a little bit about illusion and coverage, and then we will move on to Q&A. We should have about 10 minutes for questions and answers. So I'm going to F11 out of here. Okay, back to my deck. So illusion. As we said, illusion is a measure of, are my non-responsive predictions reliable? Are the documents that are that big pile of purples on the left, that is all the time and effort I'm saving by not reviewing predicted non-responsives, is it safe to do that? Is it reasonable to do that? So mechanically in the system, I would stop my prioritized review and start my illusion test. Or if I start my illusion test, it will also stop the prioritized for me. But when you click this button, it says, are you sure? You say yes. And then what it's going to do is it's going to make one last model build. So it's going to say, I'm going to take, if there's no documents that have been coded recently, then it won't bother because it's already got the latest and greatest. But it's going to say, let's take all the latest and greatest information. It's going to roll that into the model, and then it's going to predict all the documents. At that point, you're going to set the thing up. So setting it up basically consists of defining what is the sample you want to take, the random sample you want to take, and who are the reviewers that are going to review the illusion test. So the sample can be specified either as a fixed number, if you want to use your own calculators, for instance, or you just say, I only have time to do 400 documents, you could do 400 documents, or you can say statistical, give a confidence level and margin of error, and the system will calculate the sample size for you. But again, the population it's sampling from is the not yet coded documents that are below the rank cutoff. So the rank cutoff is what you're proposing that you're going to discard everything to the left of. So if it's a 60, then that means a 59 and below. If it's a 51, that means a 50 and below. In this project, it actually doesn't matter. A 60 and a 50 are the same thing because there's no uncoded documents at the right side of the graph. You can see the graph is completely empty along the right side here. There's nothing left. So in this case, the rank cutoff could be either of those numbers. But you choose a rank cutoff, it takes a sample, and then it's going to feed that sample to your reviewers. So you see it's lit up, it's blue, we're ready to begin. The reviewers are going to see that same blue bar in that same view that they saw the whole time. So there's no difference from the reviewer's point of view, whether they're coding an illusion test or whether they're coding a prioritized review or whether they're coding a coverage review. In any case, it's going to just look like that big blue button and you click start review. Now, some people have told me their reviewers tend to do things wrong. So could we make the button say, don't click here, and that will increase their chances of clicking on that button. Product management has not prioritized that fix yet, but yes, tell your reviewers, click the start review button. Let's be kind to our reviewers and let them go. So they code their documents. At some point, they've coded all the documents in the illusion test. We definitely do not advise that you skip any documents. Make sure that they've coded all those documents, and then you're going to get this report screen. And this basically says, Dear Administrator, here's the status of things. What do you think? So a couple of the things that it shows me. The illusion rate on the sample. 3% of my sample was coded responsive, 97% was coded not responsive. It shows me what that projects onto the population with the margin of error. So if the margin of error in this case is huge, it's 7.7%, well, that's between 0 and 10% of my documents I can infer are responsive with a 95% probability. So you can take a look at that and say, okay, what does that mean to me? This 164 number here is basically 3% of my discard pile, that population of uncoded documents. So it's a little bit of a funny statistic. The 0 to 586, likewise, is just the projection of that range onto that discard pile. So if I had 10.7% of my documents were actually responsive, that would correspond to 586 documents that are responsive that the system's predicting non-responsive. And then lastly, we have this curiously named pending document. So pending in this case just means not yet factored into the model. So the model hasn't seen 157 documents. Now in this case, they're the 157 documents that are from our illusion test. But it could also be that one of your reviewers is just coding documents on the side while the illusion test is in progress. So that number is going to be at least as many documents as were coded in the illusion test, but it might be more if other documents were also coded since the last model build. So based on these numbers, I would say, if someone says, what's a good illusion rate? My first answer is, do you know your richness? Do you know what percentage of your documents are responsive approximately? Because if 20% of my documents are responsive and I'm getting a 3% illusion, that's a pretty good rate, right? That's 7 times more efficient than 20%. So at this point, I would invoke reasonableness and say, is it worth coding 30 documents to find every additional responsive document or not? Or is that kind of outside the reasonableness of the case? If your illusion rate is 3% and your richness is 2%, then that means that your discard pile has just as many responsives as you started out with as a percentage of responsives. Now, if your margin of error is really high, maybe that's what maybe you take a bigger sample and try to prove it with more granularity. But that's it for illusion test. I don't want to make this whole webinar about illusion. So let me talk about coverage, and then we'll take some questions. We saw the statistics tab before. You can get to statistics with illusion as well. So a few words about coverage. So coverage review is basically a new Q type. And coverage review is for trying to get the model classifying well as efficiently and quickly as possible. So coverage review doesn't care about serving up a lot of responsives. Coverage review cares about serving up a lot of documents that will help you classify quickly. So when do we use this? I'm working with someone that used it recently because they had a second request. They did not have to get eyes on the documents. They just had to get them out the door as quickly as possible. So they built a classifier. They classified them. The illusion rate looked good. They did a little sample to predict recall. That looked good, and they produced them. Another example is an incoming production. There's absolutely no reason that I should look at every single responsive document coming in. Hopefully they're mostly responsive, since that's what they're supposed to be. But I might want to just prioritize them. And then go cherry pick them. And then a third use case is kind of like this. Well, I don't want to use the prioritized review because X, because I love reviewing by email thread, or because I want to focus on just custodian XYZ first. Or now there's ways to do that with a project, frankly, but you could also do it with this. So I'm gonna use coverage to get a quickly trained model. I'm going to update ranks, and then I'm going to embark on some other workflow. So the approach here is it's set up just the same as any other queue. The reviewers are going to code documents until either there's some sufficient separation, or maybe I take a sample and I like what I see with my sample. If I take a sample manually, the way this works is it basically focuses on that middle. It focuses on the scores right around a 50, and it's going to work its way out if and as it starts exhausting those scores. So by definition, it's going to be focusing on some of the documents that it's confused about, or that it's not clear on. And you use an illusion test to basically say, okay, the model looks good. So it's efficient. We talked about that. You don't have to look at all the responsives if you're going to be doing other things with the predicted responsives. And it really does open this up to more and more workflows for what you're doing with those responsives. And same thing with non-responsives. It allows you to just set those guys aside and then go embark on your workflow. So you start the review. We saw that with the other review types. The big blue button is exactly the same as the other review types. Case admin is watching the project. What do they see? They see, this is a prioritized review we saw before. Here you see a coverage review. The main difference here is there's a lot of purple documents on the right. We're not exhausting the unreviewed documents on the right. We're actually focusing on the middle. You see the middle is really burned down there, but there's quite a few. In some cases, you may have hundreds of thousands of predicted responsives at this point if you had a huge project. So you're not trying to get rid of all those in this project. You're just trying to get this model good. We validate with an illusion test, as we just saw. The key point, do not forget this, if you code a few thousand documents in coverage and you like your illusion test, you still need to deal with those predicted responsives. So you're really focusing on that right side of the graph, whatever your cutoff was, if it was a 51, if it was a 60, if it was a 55, take all the update ranks, take all the documents with at least that score that aren't coded yet, and go subject those documents to review. So to summarize, it's an alternative to a prioritized workflow. Prioritized is definitely the easier or more simple to implement workflow. Coverage is a little more sophisticated or a little more complicated. You're spending time reviewing non-responsives early on to a large degree because you're reviewing these ambiguous documents. But if all you're trying to do is bucket as quickly as possible, you're going to get much better results here. Because if you think about it, a high-ranking document, the system's like, I am certain this is responsive. Well, if it is responsive, then you really didn't teach it very much. So this is really about teaching as quickly as possible. So resources, there's lots of links here to documentation, to webinars we've been doing, to white papers. There's recipes on this. There's always the community site, lots of people posting about that. And of course, as I said before, there's always solutions. Reach out to us with an email. We can point you in the right direction. We can jump on a webinar or WebEx or a GoToMeeting, sorry, and help you through your project or any other workflow questions that you have. So speaking of workflow questions, I'm sorry I went a little quickly. There was a lot of content to cover today, but I will dig into some of these questions and just review what we saw. Okay, let me just work through this. I will go from the bottom. So at this point, algorithm-wise under the covers, as I said, we're using the SVM model. Certainly as a company, we're looking at what are the different algorithms that do different things well. We're always looking at that. So there's a question about kind of other algorithms. It's possible certainly at some point that we would get into some of that. So the only thing you need to update ranks for is if you want to slice and dice the documents yourself. The queue is going to be dynamically always pulling the latest and greatest ranks. So you don't need to update ranks for the prioritized queue to do a good job. So as far as the connection between the indexes and the projects, there's one index for every project. Technically, you could delete a project and add and create a new project and tie it to the same index. That's not typical. Usually you don't delete projects. But basically, if you want to have 3 active learning projects, you need to build 3 indexes on the back end. There's a question about could you sample documents? Yeah, so the queue itself is pretty it just prioritizes the documents. But if you wanted to take a sample of all the highly predicted documents, what you would do is update ranks, create a search condition that says score equals 95, and then build it, and then grab a random sample of those and have someone go look at those. So there's lots and lots of flexible things that you can do. Other things are like, what kind of documents are in the middle of my graph? Update ranks, slice those, do it. Anything you're seeing in that histogram, you can't click on the histogram and get to the documents, but once you've updated ranks, you can go hog wild and do anything you want. And I've got people that sometimes don't even use the queue. They just build a project, they update ranks, and then they batch them out for some reason. So there's lots of flexibility there. We talked about minimum size. We talked about preceding it by seeding the queue by just reviewing documents outside of it. Is there a fail-safe for documents that have been coded incorrectly? It's basically what I showed, where you update ranks and then you search for documents that are high-ranking non-responsive coded or low-ranking responsive coded. That's how you're gonna boil down to the incorrect codings. When the progress chart starts to decline, that's not really a sign that things are done, but when it really gets into the very low numbers, that's a sign that things are done. So again, it's always nice to have a small sample that you use to calculate richness. And if you sample your documents and you know approximately what percentage are responsive, that's kind of where you see that line drop. If I know I have 10% responsive and the line is still at 20%, I'm still finding more responsives than randomness would imply. But once it drops into the single digits, then it's really starting to run dry. There's a question about submitting more fields than just extracted text. There's no technical reason that you cannot submit the extracted text plus, I don't know, the document name, for instance. So yes, you could do that. In that case, the system would learn, it would predict based on any of the words that occur in any of those fields. So it's not going to look for documents that have a certain word in their name, but if that word were in their name and it learned from documents that it was important, then it would classify with that. So it's really going to kind of append any other fields to the end of that extracted text and predict on everything. So I wouldn't say that's a common practice. I wouldn't say that it's like my stamp of approval recommendation, but I also wouldn't say that it's like an obviously bad idea. Things like dates and numbers, it's not really going to look at, so that's probably less useful. But you can certainly try that and reach out to us and let us know how it goes. There's a question about machine coded versus reviewer coded. So again, the reviewers are coding on the designation field. The machine is basically ranking the document, and that rank also gets associated based on the cutoff with the predicted field. So there are two different fields that both say responsive. One is because the person coded it on the designation, and one is because the document received a high score. So that's the difference. The machine and the person do not write to the same field. I guess that's the net of how to tell the difference there. We talked about doc count. Coverage review, was released in our BlueStem release, which is relativity 9.7. So if you're not on at least 9.7, you won't see coverage review yet. It is a little different than the stratified sampling approach that we took in RAR, but they're similar in their goal, which is to allow the classifier to work more quickly, or to get to quality classification more quickly. Updating ranks, all it does is pulls the scores from the back end to the front end. So it doesn't change what's on the back end. It just takes the latest and greatest scores from the SVM model, from the analytics server, and pulls them over to the front end. So there's a question about that. Do relevant coded docs only affect the model by giving higher ranks? Similar docs, or what they call is dissimilar to have lower ranks. Yeah, so coding a document is relevant or coding a document is not relevant basically gives the system some evidence that words in that document may be associated with relevance or with not relevance. So, the system will see over time that, gee, all the documents that contain the word glasses are responsive that I'm seeing. Therefore, the word glasses is probably correlated with responsiveness. And by default, words that don't contain glasses are less likely to be responsive, but it will also start learning terms that are highly correlated with non-responsiveness. So it's not actively, I think, pushing the non-responsives down. So you don't have to have any documents coded to create your active learning project. You can create it without any documents coded. If you start that queue and not a single document has been coded by the system, it's basically just going to serve up documents randomly until it has any kind of scores to go on. So we advise that you code documents before you click go on the queue, but it's not strictly required. So illusion is not a term that we invented. That's a term that's out there. A lot of the prioritized review methods use that type of an approach. So a question about doing a coverage at the start of any project. What I would say to that is the prioritized queue does mix in some middle ranking documents. So if your main goal is prioritized, I think you could maybe get the model a little bit smarter, a little bit faster, but it's going to come at the expense of seeing some non-responsive. So I could play that either way. I think the simple answer is if you're thinking of a prioritized review, use that approach. If you're thinking of a coverage review, use that approach. But yes, it's not crazy to think that you could do a bit of both. Languages. There's a question about languages. The main consideration, if you've got multiple languages, is can I have a reviewer in the queue that's receiving any document? So if the reviewer speaks only Chinese and they receive a document in English, what are they going to do? Are they just going to skip it, or are they going to code it? If your reviewers know all the languages that are in all your documents, I'd say throw it all into one project and knock yourself out. Otherwise, you might need to do some alternative workflows around that. I did cover this in a different webinar. So there's a webinar about Chinese and Japanese in relativity, and we talk about that some there. So that would be another good resource. Let's see. For incremental builds on the index, yeah, basically the way these classifiers work is any document that is coded will inform the model, and any document that is not coded will not inform the model. So adding 2 documents or 10 documents or 1 million documents to your index is not going to affect the predictions on the other documents. It'll just allow the new docs to be predicted. So there's really no incremental, there's not the same considerations that there are with conceptual. Yeah, there's a question about email subjects. Yes, email subjects are included because we filter out the headers, but not the subject itself. So yes, subjects are included. Any document that gets reviewed, whether it's a family member, whether it's outside of the queue, any document reviewed on that designation field will inform the model, will be used for the model. So if the document's got a coding decision and it's in your safe search, it will inform the model. Suppressing duplicates is generally not advised in a prioritized review because you want to see all those responsive documents in the queue. or the high-ranking documents in the queue. So we really recommend that you turn off suppressed duplicates. It's worth pointing out that these are not like MD5 hashes. These are just documents that look the same to the engine. So they might have some differences with stop words and things that we filter out, that kind of thing. Okay, I am right up against time, and I want to be respectful of that. So at this point, I would say thank you for joining me. This has been a great session, lots of good questions. Find us at solutions@relativity.com. Find us on the website. Watch our webinars, read our stuff, and let us know what you think. We're always open to hear what you think. So thank you so much. Have a great rest of your day, evening, etc., depending on where you are when you're watching this.